Hello everyone! Welcome to the part 3 of the tutorial to building your dApp. Today we'll be integrating a gas relay into the application. What is a gas relay? Well, a gas relay is a way that we can pay for transactions for dApp users. This is used for transactions that are signed by the users. Any transactions that involve transferring value will not utilize the gas relay. This is great for users that do not have any Ether, but would still like to use your platform for activities that onboard users. For example, providing a free NFT once they have registered their account on your platform. We will now take a look at how to build a gas station network application using Portis. First, from where we left off, we want to install Tabookie Gasless. Next, we navigate to the contracts folder, to the transactions.sol file, and import the 3 contracts from Tabookie Gasless: GSN Utils, iRelay Hub, and Relay Recipient. They all contain code that enables our contract to talk to the gas relay. Now let's inherit from the relay recipient. Inside your contract's constructors call setRelayHub with the hub address. This will set the trusted gas relay hub contract address so that the transaction contract knows which gas station contract is funding its transactions. This address should match the one you configure Portis to use. In this case, we will use the default gas relay provided by Portis. Next is we want to implement the accept relayed call, pre-relayed call, and post-relayed call functions. The accept relayed call function specifies the conditions that must be met for you to sponsor the user's transaction. For example, you can check if the user has many transactions associated with their address. In this case, this is likely not a new user to the Ethereum ecosystem. The pre-relayed call function gets executed before the relayed call gets sent. The post-relayed call function gets executed after the transaction is relayed. Utilizing these 3 methods allows you to specify specific functionality for your dApp. Once this is done, we can leave the code we've written during the previous tutorial as is. Next, we can deploy our contract using the default gas relay. We will do so by specifying our migrations file. First, let's duplicate the 2 deploy contract.js file that we had specified in our migrations in the last tutorial. Then let's rename this file 3_deploy_gsn_contract.js. We want to use the default contract that Portis will be using. You can find the default contract on the portis.io website. On the Portis website, navigate to the docs, then configuration, and we can see the default gas relay hub. It is the same address for all networks. We can select the main Ethereum network, but it should work for all networks, including the test networks. Copy the value and navigate back to the migrations file and paste that value as a second parameter next to transaction contract. This specifies the gas station that is allowed to make transactions on behalf of users that are using this transaction contract. Next, open up your terminal, navigate to the contract folder and type truffle migrate -- network Robson. We want to get the contract address and ABI for the updated transaction contract. Navigate to the build contracts folder. As you can see, a couple more files were generated. Let's navigate to transaction.json. This is the one that we want to get the data from. Copy the ABI and paste it into the src transaction.js file. Next, navigate to the src components sendTransferForm.js and paste the contract address. Before we forget, let's enable Portis to accept gas station relay transactions. Navigate to src services web3.js file and enable the gas relay in the Portis object. This activates the gas relay Portis integration, and since we are using the default gas relay hub, we do not have to provide any additional details. Now that everything is connected, it's time to use the dApp. Let's start the React application. Make sure we are in the base folder before running npm start. Let's navigate to the application. If we try sending a signed transaction, which is essentially a transaction that has no value, we see that it still costs an amount in order to send. What's going on? Well, It's because the contract that we have enabled in our gas station has no balance. A contract with no balance means that it will not be funded. So let's give our contract some ether. Let me show you how to do it in a secure way. First, we would like to open Code Sandbox. The URL is right here. This front-end site allows us to fund the contract by entering in our contract ID and funding the gas station contract. This application is essentially a tool to use to fund your contract. The code is open and available to view, keeping it transparent and secure. I recommend taking a look at the code for yourself, but you should be familiar with all of the concepts that we went over in terms of sending transactions to a contract and calling a contract to receive the balance of it. Let's get our contract address that we have deployed on the Robson network. Navigate to SRC, Components, Send Transfer Form.js, and copy the contract address that we have just deployed. Next, navigate back to the Code Sandbox site and paste in the contract address that we would like funded. Once you put in the transaction contract, let's fund it and send a small amount of ether to the contract. We can click Check Balance to verify that our contract is now funded. Now that that is done, we can navigate to our application and send a signed transaction, which again is a transaction with a value of 0. Input another address in the field and click Transfer. You should see that Portis updates to the transaction, costing nothing. If we navigate to etherscan.io, we can see that the transaction was successfully sent and recorded on the blockchain. We can see that the transaction that was posted 2 minutes ago was us funding the gas station. If we switch to the internal transactions, we can see that we have received our transaction from our contract. If we click on the transaction for more information, we see that the transaction was posted to the original gas station network contract. This transaction was posted by another address, which essentially confirmed our transaction to the blockchain. Finally, if we go back, we can see that the transaction has originated from our contract that we have deployed to the network. It was just acted upon and confirmed by the gas station network. For additional resources on continuing your journey exploring Ethereum gas stations, I highly recommend visiting opengsn.org. Thanks for watching.